Okay, next example, we've got f of x equals 3 square root of x, g of x equals negative 10 square root of x minus 1. All right. Let's start with the domain of each one individually. So the domain of f of x, stuff underneath, x has to be greater than or equal to 0. Easy. Okay, g of x domain is where x minus 1 is greater than or equal to 0. They're solving. So x greater than or equal to 1. There's g of x, there's f of x. Now, if we combine those together, picturing a number line, we've got, let's see, 0, 1. See, f of x says, hey, I can take from 0 and go on this way to infinity. But g of x comes along and says, well, you know, I can do from 1 on. So then they say, hey, what do you think? Let's do this together. They say, okay, wait a minute. We only both can start at 1 and go on forever. So that is going to be their combined domain, x greater than or equal to 1. Or you can say from 1 to infinity. Remember, for f plus g, f minus g, and f times g, they're all going to be the same. It's only when we get down to division that stuff changes. Okay, let's write these in really quick. F plus g, that is 3 square root of x plus negative 10 square root of x minus 1. We know by the rules of radicals that the shelf numbers have to match and the stuff underneath have to match, which they don't. So it's simply going to be 3 square root of x minus 10 square root of x minus 1. And guess what? X minus g is pretty much the same, except for that one sign change, plus 10 square root of x minus 1. Okay, f times g, 3 square root of x times negative 10 square root of x minus 1. Multiplying radicals, you multiply the numbers out in front, negative 30, and then you multiply the stuff inside jail. So x times x minus 1. And I would just leave it like that. Okay, now let's talk about this divide guy. Hey, guy. So our function would look like this. It would be f of x divided by g of x. Now we need to know for the domain where, let's write this in first. So f of x on top would be 3 square root of x. On bottom, negative 10 square root of x minus 1. I don't expect you to rationalize those. We're saving time, so we're going to leave it at this. Now let's talk about the domain, though. Domain is we need to know where does this guy equal 0? Well, we can basically just solve it. X minus 1, right, divided by negative 10. Square both sides. This is silly because you probably look at it and go, duh, lady, it's just 1. X equals 1. So x cannot equal 1, which means the domain for this guy, instead of being x greater than or equal to 1, we just leave the or equal to off. And it looks like that. Okay, domains, combine them. Now, of course, we've got this new guy, the composition. Here's the main idea behind the domain of compositions. If I asked you to find f, here's f of x and here's g of x, of g of 2. Your first step would be to find g of 2, correct? And then we would plug that into f. Well, if I try and plug 2 into this function here, we end up with 1 over 0. Ah! Oh no! Oh. Get out of there, stupid box. It was going to be funny till that guy showed up. No! No! Can't divide by 0. No! So in our domain for this composition, we can't divide by 0. Or sorry, yeah, we still can't divide by 0. So if there's a restriction on the inside function, you have to name his domain first. So for D right here, your restrictions are that x minus 2 has to be greater than or equal to 0. That's the restriction for the root. But also, x minus 2 cannot equal 0. Do you see where they both come from? One of them is just the radical part. X minus 2 has to be greater than or equal to 0 so that we don't get a negative underneath. Also, this square root of x minus 2 cannot equal 0. So, looking at this one, that says x has to be greater than or equal to 2. This one right here, x minus 2 cannot equal 0, so x cannot equal 2, solving that one. Okay, then we're going to combine these two, and our domain, just for g, is that x has to be greater than 2. This is g of x's domain. So anytime there's a radical in the denominator, there's going to be a couple restrictions on it. And that's it. I mean, we have to be positive inside, so it has to be greater than or equal to 0 in there. But it can't be equal to 0 because that would give us division by 0. So when it comes to domains of the domain of composed functions, you need to know this first. You need to know what values are actually going to be able to be plugged into the first function, the f of x. Then what I would do is find the actual composition. So f compose g of x means to take x squared, but take out the x and put g in place of it. Now what happens is you end up with 1 squared over square root of x minus 2 squared, which is 1 over x minus 2. Now there's the composition. So now you're going to say what's the domain of the composition as is. Right? This guy, the domain is x cannot equal 2. So for the final answer, for the domain of the actual composition, right? This right here gave this domain, but the composition is the combined functions. Combined domains, sorry. So again, let's look at a number line. So we've got this red guy for g of x says that you can start at 2, but you can't include him, and you can go everything over here. This one down here says x cannot equal 2, which means, again, a whole, but this guy goes on in both directions, technically. Now, the final domain, the actual answer for the domain of this problem, so f compose g of x, the actual domain is going to go back to x greater than 2. Even though the final answer, the one here in blue, 1 over x minus 2, it looks like the composition of that is that x just can't equal 2 because that's the only number that would put 0 on the bottom. But because it was a combined function, because it was one function compose another function, you have to consider that first function's domain before you can define it for the final one. And that's kind of what this last piece is thinking about. Is at the end, yeah, I found the function that's being the composition, 1 over x minus 2 is then being combined, but my actual domain has to take into consideration this original domain of whoever was being plugged in. Let's try another one. Okay, find the domain of f composed g of x, where f of x equals 1 over x, g of x equals square root of x minus 2. Okay, so we're going to look for, let's see, g is being plugged in. So the domain of g, see, it's a radical with an even index, which means x minus 2 has to be greater than or equal to 0. It's okay for it to be equal to 0 this time because the g is not in a denominator right now. So for g of x, the domain is x greater than or equal to 2. Okay, set that aside for a minute. Let's go through and find our composition. We're doing f of g of x. F of x is 1 over x, but instead of x, we're replacing it with 1 over x minus 2. Okay, side note, just for this, the domain is where x minus 2 is greater than or equal to 0, and x minus 2 is not equal to 0. It's the exact same one from before, right? So we know that this domain is that x can only be greater than 2 and not equal to it. So, final domain, f composed g of x, domain is the combination of these two. Again, number lines help. 0, 1, 2. This guy up here says, hey, I can include 2 and go on forever this way. This one, though, says I can't include 2 and go over this way. This is what they have in common. So our domain is going to be x greater than 2 only. So this time, the composition is actually something that prevented it from happening. All right, next one, find the domain g compose f. So this time f is going to go first, where f of x equals x cubed, g of x equals that. Okay, let's start with f of x is the one being plugged in. So we're going to talk about the domain of f of x. X cubed has all real numbers in the domain. That's nice. Now all we've got to do is figure out what g of f is. Find the domain of that guy. So g of f equals, let's see, g is square root of 2 minus x, but instead it's 2 minus x cubed. Okay, domain of this guy. Now this is going to look weird. Away box. So let's look at it piece by piece. As the final function, it is a square root, an even root, so we need to know where 2 minus x cubed is greater than or equal to 0. Now solving that, minus 2 minus 2, negative x cubed greater than or equal to negative 2. Divide by negative 1, be careful. Divide by negative 1, x cubed is less than or equal to 2. And then you cubed root both sides. Now because it's a cubed root, there's not going to be any plus or minus or any worry about anything like that. Okay, saving a little bit of time here. There's my number line. Green one goes from about 1.25 to negative infinity because x is less than that. the orange, so the domain is going to be that.